My beloved students, hello. I am here. I am happy to be here with you today, my beloved students of first secondary school. Okay, today we are going to study algebraic lesson, which is the sign of the function. Sign of the function means positive or negative or zero. So concentrate with me here. We have here a function. This function fx equal to, if we have a function like that, fx equals to, that means that the function equal constant. Is it positive or negative or zero? Okay. Yes. We have here fx equal positive 2. So the function always is positive. Fx equal positive 2. So f of x is positive for all x belongs to R. When we see this graph, this is a function f of x equals 2 because it passes through to here. The function, it is called the y also. So y equals 2. 2 is positive. Y is positive because y here from 0, 0, 1, 2, 3 and so on. So it is above x-axis. All y here, which is above x-axis, okay, is positive. So the function fx equal 2 is positive in its domain, which is x belongs to R. Look here to see again the function fx equal negative 3. Fx equal negative 3 here, or y equal negative 3, it is negative all the time because it's constant and it is downward of x-axis, so it is negative. The function negative for all x belongs to R. So when we ask me what is the sign of this function, I told him that it is positive. It's positive where for all x belongs to R. And if x here equal negative 3, it's constant, so it is negative for all x belongs to R. Let's see another function here. If we have a function as fx equals x, if you would like to graph it, it will be like that. Fx equals x here. Where is positive? Positive here, all these parts, and negative here, downward of x-axis. So it is negative here. So f of x is positive for all x belongs to what? Belongs to from 0 open to infinity, like that. And f of x is negative where this part, which is represented by x-axis here, starts from negative infinity here to 0. So it is negative for all x belongs to negative infinity and 0. 0 is open, but this function equals 0. When it is equal 0, if x equals 0, when x equals 0. So this function, positive in a part of x from after 0 to infinity here, and negative this part of x, which is from negative infinity to 0, and it's equal 0 at x equals 0. Look here, to see general form of first degree equation. We have here first degree equation. First degree equation called linear equation because when we graph it will be straight line. So we have here f of x equals bx plus c. B is a coefficient of x and c is a term which is free of x or absolute term. Fx equal bx plus c. If you would like to find out where or in what domain or part of x equal negative or positive, we put bx plus c equals 0 here. So x equals negative c over b. When x equal negative c over b, the function will be 0. So f of x here equals 0 at x equal negative c over b. But when x greater than negative c over b, this part here, it will be as the sign of b, the sign of coefficient of x. If the coefficient of x positive, then this part will be positive. If the coefficient of x negative, this part will be negative. And vice versa for this part. The function will be opposite to the coefficient of x. If this coefficient positive, then it will be negative. From negative infinity to the number negative c over b. And this straight line may be like this. Straight line here. If b is negative here, if b is negative, it will be like this straight line. But if b, which is coefficient of x, be positive, it will be like that. And this point here is negative c over b. And this one also negative c over b. This is generalized. Let's see if we have a specific function. If we have here a function as fx equals 3x plus 6 here, and we would like to find out where is it positive or negative, or we would like to discuss its sign, positive or negative or 0. First, we have to equalize this function by 0. So 3x equals negative 6, and x equals negative 6 divided by 3. So x here equals negative 2. Negative 2 is very important for us. And if we would like to represent it graphically here, we have here y-axis and x-axis. This is ox dash. This part is positive, this part is negative. oy dash. This part is positive also, this part is negative. So if we would like to represent it graphically, just put x equals 0 and y will be 6. So the point equals 0 and 6. And put y equals 0 here, so x equals negative 2. X here equal negative 2. And join these 2 points. We have a straight line here, like that. And we know that all the part above x-axis will be positive. But all the part downward of x-axis will be negative. So if we divide these parts, we can draw the number line here like that. We have here negative infinity and positive infinity for this part, and we have negative 2 here. At the negative 2, the function will be 0, of course, because at the first, we calculate 3x plus 6 equals 0. This is the function equals 0. So when we put x equal negative 2 here, 3 times negative 2 equal negative 6 plus 6 equals 0. So when x equal negative 2, f of x here will be 0. This right part will be as what? As the coefficient of x. Is it positive here? Yes. So this part as the coefficient of x. And this is its opposite part. So this part is negative here. So when we talk about this function, it will be if x is positive for all x belongs to all the numbers of x which are greater than negative 2. So from negative 2 here to infinity. And it's negative. It's negative for all x belongs to from negative infinity here to negative 2. And this function will be 0 at x equal negative 2, of course. So this function will be positive between negative 2 and infinity, or after negative 2 to infinity. And it's negative here from negative infinity to before negative 2. And we would like to find out the sign of some other functions. Okay? My dear students, the function here is very important for us to discuss its sign, because in secondary, inshallah, you will be needed. So concentrate with me to find the sign of some equations here. If we have an equation here like that, if f of x equals x power 2 or ax power 2 plus bx plus c, it is a quadratic function. A is the coefficient of x power 2, and concentrate about a very much, because it is a sign of x power 2. If it is negative, it's different from positive. So if we have a quadratic function like that, and if we have the function and its representative here like that, if this part, this point here L, and this point is M, so L and M will be the roots of the function. We know that the intersection points of the curve and x-axis, they are the roots of what? Of the quadratic function. Look carefully at this part. This part is above x-axis, and this is y-axis, 0, 1, 2, and so on. It's positive. So y-axis here positive. So this function will positive at this part, and also will positive at this part. But this part, which is downward of x-axis, of course it will be negative. So if we would like to divide it or discuss the sign of it, we will be say that this function, which is f(x), is positive here for all negative infinity and L open. This part is positive from negative infinity here to L, which is the first root of the quadratic function or quadratic equation. And union, this part this part from M open to infinity. So it's positive this part and this part, from negative infinity to L and from M to infinity. Okay? Or we can say that this function is positive on R except this part. This part is what? Is from L to M, and they are closed. If we want to find out the negative part, the function will be negative for all x belongs to what? Belongs to from between L and M. And concentrate and pay attention, L here is open and M is open because at L itself the function will be 0, and at M itself the function also will be 0. So we cannot say that's negative or positive. So when discuss about this part, it's negative, but between L and M. And this function fx here equals 0 for all x belongs to what? Belongs to L and M, which is the two roots of the function. Let's discuss about some functions here, especially the quadratic function. Quadratic function, it's important for us to find out where is it positive or negative. So we have another equation here. If we have f of x equals x power 2 minus 5x plus 6. We know that if we would like to represent this function, we will draw y-axis here and also x-axis like that. Here is ox, ox dash, oy, and oy dash. And we will discuss about the roots. What is the roots of these two functions? If we would like to find the roots, we put x power 2 minus 5x plus 6 equals 0. So by factorization, it will be x and x, negative and negative also, 2 and 3. So it's x equal 2 and x equal 3 are the two roots of this function when equal 0, of course. Where is 2 and 3? If we put here 2 and here 3, and look carefully at this, what is the coefficient of x power 2 here? The coefficient of x power 2 is 1 or positive 1 here. So I expect that the function curve will be upward. So it's like that. Okay? If we have here the coefficient of x power 2 positive, then it will be upward. But if the coefficient of x power 2 negative, then it will be downward. So look at this function here. We have the coefficient of x power 2 positive, and we have the two roots, which is L and M here. L equals 2 and M equals 3 as the two roots of the function. So look carefully. This part is positive, and this one is positive here, because y is in this part. Y represents the function of the quadratic function. And we have this part will be negative here, downward of the x-axis. So this function will be positive. Where is positive? For all x belongs to what? All are real number except this part, which is from 2 to 3, closed. Are here all numbers except from 2 to 3. and where it will be negative, the function will be negative for all x belongs to after 2 and before 3 directly. Yes, concentrate that it's negative here after 2 and before 3 directly. So 2 here is open and 3 here is open, because at x equal 2 and 3 the function will be 0. So the function here equals 0 where, or when, at x equals 2 or x equals 3. And we can say that if x equals 0 for all x belongs to 2 and 3. Okay, we notice that when the function has two different roots, when the function has two different roots, you will remember about discriminant. Discriminant will be b power 2 minus 4ac, and when this discriminant greater than 0, then the quadratic function here has two different roots as 2 and 3. So the function before 2 will be as the coefficient of x power 2. This coefficient of x power 2 here is positive, so it's positive. And this part will be opposite the coefficient of x power 2. So it will be negative here. It's opposite. And this part will be as the coefficient of x power 2. So we can say that as opposite as what and opposite what and as what. This part is as the coefficient of x power 2. This part is opposite to coefficient of x power 2. This part is as the coefficient of 2. So we will divide it into 3 parts to discuss the sign of the quadratic function. So we will deduce about when the quadratic function has two roots. So we will divide it into 3 parts. The first part is as the coefficient of x power 2. The middle part opposite. The last part will be as. So concentrate with me to draw a number line here. If we have two roots, or the discriminant will be greater than 0, will be right here. This is negative, this is positive, infinity. This is x, and this is of x. If we have two roots here as L and M, L here smaller than M, so we put it on the left of M on the number line. So here at L exactly it will be 0, and at M the function will be 0, but these parts, as we said before, will be as, opposite, and as what? As the coefficient of x power 2. So this function, which we discussed before, which is x power 2 minus 5x plus 6, and we have two roots for it, which is 2 and 3. Okay, we find out that before 2, which is from first negative infinity to 2 here, will be as, and between 2 and 3 will be opposite, which is negative, and after m to infinity will be positive as. So this is positive, so it's as here will be positive, opposite here will be negative, as will be positive. And specifically for this function, the two roots will be 2 and 3. So we can say that fx here is positive for all x belongs to from negative infinity to 2 union 3 and infinity. Or we can say x belongs to R except from 2 to 3 closed. But if x is negative here in this part, which is opposite to the coefficient of x power 2, which is from 2, x belongs to after 2 to before directly 3, and the function will be 0 for all x belongs to the set 2 and 3. When the function equal to the x equal 2, then the function equals 0 here, and if we put x equal 3, then the function equal be 0. So let's discuss about some other functions which quadratic function. We discussed only about the quadratic function if we have two roots, but if we have just one root or two equal roots, we'll see about this function. So concentrate with me. If we have here a function like that, if x power 2 x equal x power 2 minus 6x plus 9, and we would like to factorize it, so it will be like that, x minus 3 and x minus 3 also, so the answer will be 0. Or we can put it like that, x minus 3 all equal power 2 equals 0, and x minus 3 will be 0 here, so x equals 3 only. Or it has two equal roots here. If we have something like that and you would like to graph it, we will draw y-axis and x-axis. Here OX and OX dash, OY and OY dash, and of course it will be touch this part at 3, and it is positive here, is the coefficient of x power 2 positive, so it will be upward. So the function will be upward and touch only here 3. So here is positive now. Look carefully. The function will be positive in this part and also in this part, but equal 0 only when x equals 3. So if we draw the number line here, like we said before, and we have negative infinity here and positive infinity, and we have x here, of x here, and we have only 3 as a root. Add 3, the function equals 0, and look careful at it as this is positive as the coefficient of x power 2, and this is the positive as also the coefficient of x power 2, so it's as. So it's positive here and positive here. So function is positive for all x belongs to R except one element only, which is 3. And if x equals 0, just add x equal 3. Okay, my dear and beloved students, we have now a little break and we will return again. So don't go away. Okay, hello again, my dear students. We discussed about the sign of quadratic function, and we have discussed about two functions. If the function have two roots, two different roots, then it will be as opposite as the sign of the function. And if it has only one root or two equal real roots, then it will be as the positive or the sign of the function and equal 0 only at this root. So concentrate with me to find out another one. If we have here fx equals x power 2 plus x plus 1, when we try to find out the roots of this function, it has no real roots, but it has two complex roots, and discriminant b power 2 minus 4ac of course will be less than 0 or negative. So when we graph it here like that, we will find out that this function will be completely lies upward of x-axis or sometimes downward if the coefficient of x power 2 is negative. So all this function will be positive, all of these parts for all x. So we say that fx is positive for all x belongs to R. Here x and x dash, the negative part and the positive part, this function will be positive because it lies completely upward to x-axis. It lies in the positive part of y-axis, so the function always positive as this positive. And if we have another function here, negative x power 2 plus x plus 1, it will be like that, and it will be lie completely downward of x-axis, so it will be negative here. So the function is negative for all x belongs to R. And if we would like to draw a number line here like that, so here x, here fx, negative infinity and positive infinity here, so the function will be as the coefficient of x power 2, which is negative here, so it's negative all the time. So now we have three types of quadratic equation. First type has two different real roots, so two parts with the first part and last part will be as the coefficient of x power 2. And if we have two but equal roots, we will have as and as, but the number of the root only will be 0. And if we have no real roots, so the function will be upward of the x-axis completely or downward, so it will be as the coefficient of x power 2. Let's see another function, another example for this. If we have here fx equals x power 2 plus 2x plus 1, when we would like to find the discriminant b power 2 minus 4ac, b here is 2, so b will be b power 2 will be 4 minus 4 times a, which is the coefficient of x power 2 here, which is 1, times c, which is 1. Calculate this number. This is 4 minus 4 equals 0. When discriminant equals 0, then we have two equal real roots. And if we have here the drawing or the graph, we will find that the two roots will be 1, because if we factorize this part, this function here, when it equals 0, we will factorize it. It will be x plus 1 and x plus 1 equals 0, or x plus 1 power 2 equals 0. So x equal -1. And the coefficient of x power 2 will be positive. So the function will be completely lies upward of x-axis here, but it passes through -1. So when we draw the number line like that, here x and here fx, and we have only one root, which is -1. -1 here makes the function equal 0. So it will be as what? As the positive of coefficient of x power 2. It will be positive here and here. So the function will be positive, is positive for all x belongs to R except -1. And fx equals 0 at only x equals -1. Okay, so the function will be positive before -1 and after -1. So it is positive from -infinity to infinity except at -1, because at x equal -1 the function will be 0 here. Okay, let's discuss also about solving quadratic equations. If we have quadratic equations here like that, we will applicate the sign of the function on solving the quadratic inequalities. If we have an equation of second degree and it's greater than or equal 0, or less than or equal 0, or it's equal 0, so we'll be discussed about it, and the question will be solve in R x power 2 minus 5x plus 6 greater than 0. We have an inequality here. How can find out the solution set of this function or this equation or this expression? We know that if we consider it a function, the function will be here x power 2 minus 5x plus 6, and we have known that the graph of this function will be like that. If we have x-axis here and y-axis here, so the function will be the two roots as we know, and when put it equal to 0, the two roots will be 2 and 3. Why? Because when factorize it will be x minus 2 and x plus minus 3 also. So x equals 2 and x equals 3. So we have two roots here, which is 2 and 3. And if we would like to graph it, of course, it will be like that. And we have part here. This part is positive. This part is positive also. But this part is negative, as we said. So when we would like to solve this inequality, we would like to search or find out where this function or this expression greater than 0. Greater than 0 means positive. So look at this graph to search or to tell us about the positive part. The positive part here will be solution of this inequality. So solution set here equals R except from 2 to 3 closed interval. This part is positive, this part is positive, which is all real numbers except 2 and 3. So the solution set of this inequality here equal this solution set R except 2 and 3, the interval 2 and 3. Why? Because from negative infinity, before 2 will be positive, after 3 to infinity will be positive, and we would like to find out the solution of this part greater than 0, which is positive. So the function positive here, so the solution set here is R minus 2 and 3. If we write the same function or the same inequality here, but it will be x power 2 minus 5x plus 6, but now less than 0. We want to find out solution set of this inequality. It now less than 0. So again, if we draw this function, we have drawn it from some moments. It will be here 2 and 3, and we want to find out solution of this inequality, which is less than 0. Less than 0 means negative. Where this function will be negative here? This function will be negative here between 2 and 3. So solution set here will be 2 and 3 open. And if you would like to discuss about the number line here, and we draw it here like that, from negative infinity to infinity, and we have x and fx, we know that function will be has two roots. The two roots will be 2 and 3. Add 2, the function will be 0. Add 3, the function will be 0. And this part will be as what? As the coefficient of x power 2, opposite as. So it's positive here, negative here, and positive here. And we would like to find the negative part. Negative part is between 2 and 3. So solution set, as we said before, it's 2 and 3, open at 2 and open at 3, because at 2 the function will be 0, not negative. And we would like also to write the same question for x power 2 minus 5x plus 6, but now greater than or equal 0. We know that we have keeping it. We know that this function has two roots. If we write it a function, as a function here, x power 2 minus 5x plus 6, and you put it equal 0, so its solution will be 2 and 3 here, as we said before. This is x and fx. It is as here, opposite as. So the coefficient of x power 2 positive, so it's positive here, negative there, and positive here. So we would like to solve this inequality here. This inequality talk about greater or equal 0. So we would like to find when it is greater than 0, the positive, when it's equal 0. It's positive in this part and this part. So from R, except this part, which is 2 and 3. But we want 0 also. And 2 itself makes the function or this number equal 0. So we'll close it here, or open it here. Sorry. R minus 2. So 2 will be with R, which is make it greater or equal 0. And open there. Or we can write it as 2 and 3 here. This part will be except this part. So the solution set will be R except 2 and 3. Okay? Or we can divide into two parts. Will be negative infinity to 2 and 3 to infinity. This part and this part will be give positive, so closed here and open here, closed here and open here. This is a union. So solution set will be R except 2 and 3, or from negative infinity to 2, union from 3 to infinity. So solution set of this inequality will be this or that. So if we transfer to another question here, will be x power 2 minus 5x plus 6 smaller than or equal 0. Now we have a part of the number line here. This function will be gives, here is 2 and 3 also, the same function, 0 and 0. This part is negative, this part is positive, this part is also positive. So we would like to negative part here and 0. 0, it gives it at 2 and 3, but negative part it between 2 and 3. So solution set equals 2 and 3 union the set of 2 and 3. It will be 2 and 3 but closed now, because from 2 to 3 it's the part of negative which is less than 0, and the part give zeros to the function. So x power 2 minus 5x plus 6 less than or equal 0, its solution set will be from 2 to 3. We would like to find out another solutions. If we have x power 2 plus x plus 1 and we would like it to be greater than 0, solve this inequality in R. We know that this inequality has no real roots, because b power 2 minus 4ac less than 0, and we know that graphically this function will be upward to x-axis like that. It will be like that, so it's positive all the time, and we would like to find out where is positive. Greater than 0 which means positive. This inequality, its solution set will be R. Why? Because we would like to find out the positive part. Positive part is all the function, so it is positive from negative infinity to infinity here, so its solution set is R. But if you ask us about x power 2 plus x plus 1 less than 0, the solution will be completely different. We search about negative here. Where is negative in this function? No parts, no points. So solution set here will be phi. Where will be phi? Because this function doesn't equal negative number at all. If we try to test it, just put x any number, say at x equal 1, this x will be 1 power 2 plus 1 equals 3. So 3 greater than 0, so it's positive. So we know that this function positive all the time, or at its domain from negative infinity to infinity. When we would like to solve this equation, when x power 2 plus x plus 1 less than 0 means negative, cannot exist. We have no points of x makes this function negative. So solution set equals phi. And if we try to solve them, another inequalities like that, if we have x plus 5 multiplied by x minus 1 greater than or equal x plus 5, it's little bit complicated, but we have know that we have to expand this part. X multiplied by x equals x power 2. X multiplied by negative 1 equal negative x. 5 multiplied by x equal 5x, and 5 multiplied negative 1 equal negative 5, greater than or equal x plus 5. And we would like to simplify it. X power 2 here, and we have negative 1x plus 5x will be positive 4x minus 5. And try to transfer these parts inside the inequality. This will be negative x and negative 5, still greater than or equal 0, because these numbers we transfer it on the left side. And try to simplify it again. We have x power 2, 4x minus x will be positive 3x, minus 5 and minus 5 will be negative 10, greater than or equal 0. We have a function here, and this function, if we try to solve it, we will have the two roots here, x plus 5 and x minus 2. So it will be x equal negative 5 and x equal 2. So we have two roots here. If we have two roots here, if we have drawn the number line x and fx, we have two roots which negative 5 and 2. At negative 5 the function equals 0, at 2 the function equals 0, as opposite as we said. So look here at the function, the x power 2, the coefficient of x power 2 equal positive, so it's positive here, negative here, and positive here. So we want to find out greater than or equal 0, means positive and 0. Okay, so solution set equals R except negative 5 and 2 open. And this is the solution. My beloved students, I am happy here to be with you again. Now we close the algebra for this term. We finished the algebra. Next time, inshallah, we'll discuss about geometry. So be happy and goodbye.